Welcome to the Inspire Around the Globe conference. We are here with Bluebot Builders, Project Peacock, and Turbo V8. I just talked with Open Source, and they told me they can't attend today's conference. They got the date wrong, so they'll probably join and present tomorrow's conference if you want to see them. So I guess we can start. Um, can Project Peacock start?
Yeah, for sure we can. Can you hear me?
Yes.
Alrighty. Let me share my screen real quick. So, how do you want to start this, boys? So this was our 10th anniversary season. I apologize about my printer in the background. So yeah, this is our 10th anniversary season. We wanted to go a little on the big side and like big and bold and get our name really out there, and along with making our presence known and like setting a name for ourselves. So we have a very, very nice looking front page, and we highlighted our 10th anniversary season. Um, and like a picture of the team. I think that's what the judges always like to see. Um, Jackson or Anthony, do you have any comments on that?
No, that's a fair.
Yeah. So moving on to meeting the team page. Um, the judges always like to see everyone and along with their individual um, contributions, like their role. Like last year, I was team captain, head mechanical, and on drive team, right? And Anthony was drive team and software. Jackson was lead designer and drive team. And also sharing your proudest moment. The judges also likes to see that as well. Um, Making sure that we highlight all of the required and what is it? The recommended or encouraged points is key for getting us inspired. Or because what did we get? We get like third inspired at state or something like that.
Yeah.
Okay. So, Anthony, do you have any comments on this one?
Yeah, one of the things is personality and personability is was very key because making sure that each person was highlighted and it wasn't just okay, this is the person, this is what they does, being able to kind of make it personal and say, yeah, proudest moments, and just those kinds of things really helped to make us stand out because you can just say, yeah, I was Anthony, I did draft team and software and leave it at that. And but just adding those proudest moments and sometimes, adding the things like the robot at the bottom, for example, was something that was very it was out of the box and different, but it really helped to just uh make sure that you guys stand out above the rest of the teams because yeah, every other team could say, yeah, this is what my teammate, this is what we do, but being able to make sure that you guys say, okay, this is what my proudest moment is something that also really helps to just emphasize that.
Alrighty, moving on, we have our fundraising and sustainability page. So we go over our team branding. Um, I can't remember which award that's for. Um, Team branding and um, is I think I want to say like motivate or something like that. That will that they want to like include. So we always start matches with Picard when we put that in bold, right? It's because like that is something unique to um like be different than and like stand out to other people. Um, then we go over our season highlights. So, like hosting summer camps and beta testing some products and fun behind the bot, stuff like that. Um, then um, We also go over our team goals. Our team goals is also another encouraged thing on the in some of the awards is sharing those and presenting those, and how like what are your steps to going about achieving those. Um, so like our usually one of our main goals is going to Worlds for in this year, and how do we do that? And increasing our member skills, improving team sustainability, and spreading first globally. And by like participating in these kinds of conferences, we can help spread first globally. Anthony, do you have any comments or Jackson?
One of the biggest things with the portfolio is telling the team's story, and that's why you end up talking about your team branding and your introduction, your goals, and your highlights, is because the portfolio is what you give to the judges to tell the story of, in this case, Project Peacock, and to tell them of our 10th anniversary season, which was last year, and how we did everything that year and why we do what we do. And just because some of these things can help them lead to questions in during interview time or whenever they come around in the pits or things like that. But the whole point of a portfolio and trying to help make sure that you guys are telling the story of the team.
Right. And then also, but like not being too wordy, but like keeping it concise, keeping it straight to the point. That's, yeah. Also, our next fundraising sustainability page, we have our actual sustainability plan. I believe that's also another one of the encouraged um, points on some of the awards. Um, and we list some of the things that we need that we want to do and to keep our team alive in future generations. Um, and we have a SWOT analysis, like how can we improve ourselves and how can we make the team better for seasons to come and for us to still be a good team whenever we're gone, right? Um, keeping keeping sustainability is a very very important part of the team and making sure you're able to continue on into the next season. And we also, at the bottom of the page here, we included our donations, expenses, and revenue. That's always nice to include if you have your numbers right. Um, and then some of our sponsors as well. Anthony Jackson.
Yeah, something that I think is really important is to share not just your strengths, but also your weaknesses and how you overcame them. Because that's what the judges really want to see is your process throughout the season of evolving.
Right, right. Going on, we have our mentor page. This was our mainly our Connect Award page. But it's just going on like how do we actually connect with our mentors? Like how do we learn from people? Like we have all of our mentors and what they're like specialized in or in what they can do. Or in what they do for our team in a sense. And like we toured facilities and we went on to highlight those facilities. And that's important just to pretty much say like this is how we did it, you know. Making getting your point across, but still being nice and concise. Um, Anthony Jackson.
One of the biggest things about the portfolio is we make sure that we go through the criteria of each award and emphasize that we hit both the required and the recommended criteria because those are out and available for the public, and we try to make sure that we hit both of those things just so that we can just have that edge on everybody else because, most people may just do the recommended, but trying to make sure that you're telling both of those things is really key.
All right, so now going into our outreach timeline. Last season we did a lot of outreach, so we have multiple pages for it. Um, so highlighting your event, being short and concise, um, including the amount of people you impacted and your lesson learned from those events is what you want to have. The lesson learned is what the judges also like to look out for. Um, we have quite a few lessons learned, especially going into the technical side of things. And so we all we did was we just simply outlined our season from going from June and to September, and then going on from September to what was it, April. Going down, we went into November, December, and February, right? So just still highlighting those events and also making sure to highlight your number of outreach events, hours served, and people impacted, all in bold. It's like that's saying like, hey, we impacted this amount of people, and making sure to highlight that and get that across to the judges is nice, like being able to do that fairly easily and simple. It was like, oh, this is bold on a page. You can easily see that. So, Anthony and Jackson.
The shorter in some of these, the shorter the better. Judges only have a certain amount of time to read the the portfolios, so making sure that you guys are staying as concise but yet clear as possible, diagrams, pictures, all those sorts of things are what really helps to make sure that everything is there.
Yeah, and that's something we're still working on. Our portfolios are still pretty wordy. We've come a long
No,
way. Freight Frenzy, it was just walls of text, so definitely don't want that.
right. All right, Jackson, you want to head this off?
Yeah, so for our something we always try and look at is our design process. We try to show every step along the way as much as we can so that the judges can see um, what we've done. So we have our design process flow chart there. Um, Peacock missing the K. Um, and then we also have our lessons learned throughout the season. And then we do design reviews with our mentors before we ever manufacture anything to get their input on our designs. Yeah.
Yeah. So like being a like doing our design processes definitely helps, like getting input from engineers. That's a very useful and very helpful um experience. And mentors are a very valuable resource, and you should use them as much as you can, so that y'all can grow in your knowledge.
Yep. So here's our V1 page. We wanted to show and detail this robot so we could contrast it with our new robot so the judges can really see how far we came throughout the season. Um, so we show the strategy. We had a four bat high basket. Then the specs, 435 RPM drivetrain, pivot arm, just all the basic stuff. Don't go too far in detail, otherwise you'll take up your entire portfolio.
Yeah. Like if you have like a robot for your like if you have like multiple robots, just do like one page for your like first season robot, and then do like multiple for your more advanced one, Like also be sure to include your challenges, Being listing your challenges will be able to go into your V2 or your next robot that you put in here that's like, hey, we did this and this and this to solve that issue and to overcome that challenge.
Yeah, and I think this is something that's really helped us with Think in the past. We've been very strong in Think for the past couple of years. I think it's because we really show our design process throughout the entire season.
Yeah, and one of the things is the judges also like to see, uh, as part of the awards, is what lessons you've learned and how you have thought about how you can improve, and then how you decide to implement that. And we can kind of see that as we go into the V2 design, that we took a lot of what we learned and made it to where we didn't have to worry about that and made it better.
And so here's our overview page for V2. Um, we really tried to highlight all the improvements from V1, things we learned from the past robot we applied to this one. For example, we added level 3 hang and increased the specimen, the ability to do specimens. Uh, yeah.
Yeah, and like just just highlighting the important things, but keeping it nice and concise. Like here, all we did was put bullet points, and that's you don't have to do much detail. Just highlight the most important things, and that like go along with your game strategy, and then you're fine. Like you game strategy and key to design points. We made our robot based off of our design, and not well. We made our robot based off of our strategy, and that strategy curves our design process to like manufacture and create a robot that fits that strategy, right?
Because one of the things also is you don't want to explain everything in the portfolio, because then the judges have no room to ask questions. And then this gives them still enough detail to know about what you're talking about, but yet still gives you as many opportunities to be asking questions as you can.
Yeah.
So for our chassis design, we used the iLight drivetrain simulator to simulate our drivetrain performance, which is a big think, like math is big for that. So we make sure to include all of our motor calculations. Then explain the drivetrain mechanism, pinpoint, all that stuff. Um, yeah. Anything else on that?
Includes lesson learned from previous robot. Lesson learned. We pretty much have a lessons learned on every page, except for like the first few pages. But that's on most of our technical pages. We always have one showing like we always think all of our designs can be improved, and they're not always perfect, and so we can always be improving them, right? So showing what we can do better, the judges like.
Yeah, just being able to, being for the judges to be able to see that we reflected on the performances that we had and improved from there is something that you guys can take into this season as well with all the different things. But it really, them seeing that you didn't just build a robot and and was done, that you guys still went back and learned from what needed to be improved. And we can kind of see that with here, the active to the passive and why we did that. But being able to show that we do all this thoughtfully and we have reasons behind it, and we reflect on the pros and the cons, and we do the best from there.
Yeah. So here for our intake page, we included the V1 intake and then compared it with the V2. And something really important is to explain why you did things. Like for example, here we went from passive or from active to a passive claw intake. And so we explained like it would be easier to select individual samples out of the I can't submersible. That's right. So just explain your design choices as much as you can.
Yep, and then as you can see, lesson learned again at the bottom of the page. That's always important to us in our thought process of things.
All right, so then here for V3, main thing just adding the level 3. And then we also switched to carbon fiber to reduce weight for the level 3. And then so we just go through and explain the changes, why we made them, pretty much the same as last couple.
Yep.
But yeah, just again, so showing them every step that we take and why we do it and what it includes is something that uh, really helps to emphasize what we do and why we do it. And so we can kind of see that with this page. We can see, yeah, want to score high in auto for both samples and specimen, and we had to make mechanisms to do both. We figured out that it would be easier if the mechanisms were the same so that we weren't having to worry about multiple different mechanisms. And so we did a passive transfer so we can grab and score on different sides and have faster cycle times. One of the things we did have to play with and figure out was how we actually grabbed the sample from the robot because, sometimes getting the grabbing perfect wasn't the easiest. And then obviously we went into our total points and our ideal match if we were doing a solo, so we could kind of figure out how to do that. And then obviously the math for the thing with the lift pulleys, we had a lot of issues getting the level 3, but being able to figure that out and make that work was something that we were really proud of. Andrew and Jackson, do you guys have any thoughts or comments on it?
No.
You hit everything. So
So going into auto, yeah, we use Roadrunner and the pinpoint. We talk a lot about this. This is probably one of our more wordier pages, but we explain why we do Roadrunner, why we didn't do pager pathing that year, how we uh, use the four bar odometry pods and the pinpoint, and how we were fortunate enough to be able to test those. Uh, we then go into our autonomous routine at the bottom and on the right side about our pathing, and we have the arrow matches the color in the box, so you can kind of see, okay, on the specimen, the green arrows are for splitting and sweeping the samples into the human player station back and forth. So it really allows for the color code so that judges can see that. And obviously, again, we have lessons learned at the bottom, and there's a lot of different, we learned, yeah, there's a lot of different ways to be able to make these autonomous programs and how to go from there. So, Andrew Jackson.
I, you hit everything. No thing. Like color coding it to match the different pathing um, is is also another neat idea. Just to help the judges. Because like some of the judges like don't know the game very much, and so being able to like somewhat like in a sense dumb it down a little bit, like make it easy for them to understand, and make it clear, is also very helpful. And also bolding things make it stand out to people. It's like, hey, this is important. Um, those kinds of things always help show something. So
Yeah. And then our last page obviously is our driver enhancements. We took, what we've learned over the years, less buttons better. And if we can automate mechanisms, let's do it to help it be more successful. So we had a lot of toggle controls. So things like opening the claw were the same button, deploying the intake was the same button. So really trying to help optimize speed and automating mechanisms. So, for example, after we would grab a sample, the entire uh, time for when the intake would be brought in to actually transfer the sample was all automated. All the driver had to do was push a singular button. So that was really beneficial because, again, it doesn't have that many buttons. So we can kind of see, yeah, extension toggle, lift reset, lift extend. Overall, not that many buttons. There could be a lot more, but we ended up having those, and then the driver two really would just kind of help with specimen scoring and manual extension and lift if we needed it. But it was really easy because the drivers would know if they were running specimen or sample in the match, and so they could be in sync because they would know, okay, I'm touching the specimen, and I grabbed it, driver two needs to lift up. I touch the submersible, driver two needs to go down. So it was really smooth in terms of what the buttons were. And then, yeah, we have the manuals in case we need them, or in case something with the encoders or something like that went wrong, we could still manually do it. And then we obviously talk about how we use field centric because we felt that that's the what's worked the best for us over the years.
So yeah, this would be our would it be control ward page, and highlighting like the buttons is a pretty cool thing to do. Making it's like, hey, like this is an optimal set of buttons. Like it's an easy layout to know to get used to. Um, and it's definitely explaining the all the automation that you've done, the kind of driving you do. Um, that those are always very helpful to explain. Yeah. And so our last page, since we had a extra page, we wrote a little letter to the judges, saying that to like thanking them and for volunteering and taking their time to make this event possible for us, and explaining how we are this is our 10th anniversary season and how we're throwing it back to our original notebook and our original color scheme. Um, and even though we face up and downs, we would still like to share our season with you. So we thought it was a nice little thing to do, just to make it a little more personal between the judges. So, and then we have a picture from 2015 and to 2025. So just showing where we've gone from. So yeah.
Yeah, so that wraps up the portfolio. Are there any questions?
Okay, if there are no questions, I guess we can continue with Turbo V8.
All right, can you see the slideshow?
Yes.
All right, Ethan, you want to go ahead?
Oh yeah, so we're presenting pure pursuit and inverse kinematics. Okay, so TurboGate's a community team based in Pleasanton, California. Our team started in 2018. We have a team of 80 high school driven by innovation and collaboration, and are the third generation of 142259. We have been proud to earn Thinking Innovate Awards at previous events and win the Maryland Tech Invitational. Last year, we advanced to the first international competition where we placed third in our division and won the Control Award. So today we're presenting Pure Pursuit, Inverse Kinematics, and both of these algorithms. The problem is we want to move autonomously in a like curved path, so we can use like max power the entire duration, and then it autocorrects if we deviate from the actual path. So we have a pure pursuit algorithm, which is also used in games like Mario Kart. So it's smooth and curved, accurate movements. So it always looks ahead of where it actually goes, and then it converges onto the path if it's off.
All right. Last year, we the Into the Deep game was very particular on having a great transfer mechanism, and so in order to account for misalignments during robot motion, we had to compensate our arm and wrist position, basically our outtake deposit mechanism, to account for the slight shift in position of our intake while the robot was moving. Um, Another thing was we had to raise the height up of our intake as the horizontal extension was moving because our slides drooped down by gravity. So this really assured that we had a standard height of intaking samples from the submersible and we weren't, going down too far, and it was fairly constant in that way. Our one more thing that we used in inverse kinematics for was to account for the sag of the actual intake mechanism itself, or feeding back into the previous thing. Because the slides would sag, we had to account for the um, we had to account for it, and so we used the sinusoidal relationship with the height, using the weight of the intake mechanism itself and the torque produced by gravity to calculate how much we had to extend upwards. And really, by doing this, we were trying to look for and nitpick every small thing that could make our robot more consistent. Um, these weren't the major features of our robot, but they're really what made it more efficient and helped it become what it was. They weren't, changing the boundaries of what we could do, but they helped us achieve more. And it really brought us consistency, redundancy, and efficiency. Thank you so much.
Oh, that was it.
Yeah.
Amazing presentation. I think we can finish with Bluebot builders for today if they are ready. And if anyone has any questions, you can ask them. Okay, so I guess Bluebot builders, if you can present.
Okay. Can you hear me?
Yes.
Okay, wonderful. All right, I'll just share my screen. Can I do that? This one. So, so I'm Nick, and here with me today are Eli and Rylan. So we're from Team 14380 Bluebot Builders from Brisbane, Australia, and we thought today we would give a little presentation on our intake for this Decode season. So yeah, So right at the start of the season, right, we had a look at some prior FRC robots, specifically from seasons like Infinite Recharge and Rapid React. And one robot that really stood out to us was the Cheesy Poofs 254 robot from Rapid React called Sideways, which had a dual intake for intaking cargo. And then we also took a little game analysis there, right? And we thought because of all the crossing of the field from human player zone to goal, that there would be a lot of defense, especially with like a lack of protected areas in this game. So we decided to make our own dual intake system for our robot Elsa to ensure that we can always get artifacts to score throughout the game. So Eli, do you want to talk about how our intakes are powered?
Yep, sure. So we use two air motors, one for each side, one for each intake, on a bevel gear, power the roller. And so we don't the reason we have two motors, not one to power both, is because we don't always want to power both at the same time. We want to be able to have the ability to independently power them. So, if we wanted to just intake one side, we can do that. They're running at pretty fast RPM, so when we touch the artifacts, they just get sucked straight in. Yeah, Nick, do you want to add anything else?
Yeah, so just each side spins at about 2000 RPM to just allow for really, really fast intaking. So yeah, that's good. So yeah, like Eli said, the power is transferred from the bear motors to along axon bevel gears, which get the ratio from 6,000 down to about 2,000, and then there's a small speed up on the little pulleys we've got on one side to spin the actual sushi rollers, which we've got. So the sushi rollers are a product from AndyMark, and they're about an inch, I think, in diameter, and they're really, really good. And we just tested them. We tested a bunch of rollers actually, from the gecko wheels to other things like polycarbonate with cat tongue tape around it. And we just found that the sushi rollers work the best, and they have really simple, but they're also they got a really reliable grip on artifacts. So, Rylan, do you want to talk about how our intakes are compliant?
Yeah. So basically our intakes, they're not like it's not power that decides the angle of the intake. So we actually just free, and we add some compliance with rubber bands that attach the bottom of the intake arms to the robot, so they kind of snap back after an intake after an artifact has gone through the intake, and then after that we have, as you can see in the right image, there's bungee cords stretching across the transfer so that it acts like a one-way gate, so the artifacts don't bounce out after they've gone through the intake.
Yeah, right. So yeah, so basically what really happens is, because our rollers are hard, what happens is they spin and they go also around the artifact and suck it in behind it, and the little rubber bands snap them down to keep it down because of gravity. And yeah, and then the bungee cord, like Rylan said, it just the artifacts can roll through it when it's getting the power from the intake, but they can't go back out. So when our kickers are sorting the artifacts, the artifacts can't roll out one side. So that we found that to be really effective. So, Rylan, do you want to talk about the intake ramp as well?
Sure. So our intake ramp is fully customly designed in Fusion 360. It has like a profile that kind of funnels the artifacts towards the center when they're being intaken. And basically, not only do we just have the intake ramp that's 3D printed, but we actually stick some cat tongue tape, which adds some more friction, so it's easier to intake artifacts. Yeah, and then so it also connects to the bottom of the robot, the bottom plate of the robot, and the middle joining plate of the robot. So yeah.
So yeah, do you want to just give a little bit extra on how they were designed?
Yeah, so we used the loft tool, which basically you kind of profile between two planes to make a really smooth and well-rounded design of the intake ramp.
But
Something to add on about the design is the inner plate has a little bit of a cutout of it that actually effectively widens the intake. So you can see near the both mecanum wheels at the front, there's a little shape that is cut out of it that effectively makes the intake larger, just because of the nature of the artifacts. Is it can touch, like, let's say the side of our ramp, and still the sushi rollers can still grip it in and kind of rotate it around to center it into the intake to the intake.
yeah, thank you for that, Will. And then also just a little bit extra on the cat tongue. So the cat tongue we've actually tested with a bunch of different materials, and we found it from FRC. And what it does is it just basically gives a lot of grip on the artifacts to ensure that they don't kind of sit idly on the ramp and just spin in place, and just to ensure that it can grip onto the artifacts and get them straight into our transfer. So yeah, Eli, do you want to talk about what materials our intake is made out of?
Yeah, sure. So for our intake, we 3D printed it using PLA filament. Um, Obviously, we also have, I guess, yeah, that's just for our intake. We have, you can see in the picture, we use the Bambrilla P1S. Um, and so the reason for that 3D printing is great for this, since we can kind of, there's the profile that we have, it allows us to create those sort of profiles. Whereas say with a CNC intake, you'll be able to achieve the same sort of shape. So that's why 3D printing really suits the intake of.
Yeah, so we use the PLA for the ramp, and then the little arms that the rollers sit on, they're made out of like I think pretty sure 3 mil polycarbonate, and they go up and so that holds it really rigid. But the thing about polycarb is unlike carbon fiber, is it's decently flexible, so it can absorb a lot of bumps and still remain quite durable, and it works really well for our design. And then yeah, so we've through our testing of our intakes through both of our competitions and a lot of time at the studio, we've looked at the pros and the cons. So basically, let's just go through the pros first. So the pros is that it improves our cycle times. So we are able to, instead of having to spin the robot constantly to intake artifacts, we can rotate less and we can go forwards and backwards and get artifacts really quickly and efficiently. And this slows down our cycle times, obviously. Another pro is that we're quite hard to defend. So if a robot is on one side pushing us, which is our intake, trying to stop us from intaking, what we can do is we can just drive backwards and use the other intake. And that works just as fine, and we get just as many artifacts just as quick. And it's because of how we've designed it with the compliant arms and the thin 1 inch sushi rollers, the sizing is really small. So we were able to have one on each side while being still combined the width of just a regular intake that lots of other teams have. However, all designs have their cons. So one of the main cons of ours is that it requires 2 motors, one for each side. While you could, in theory, link them together with just one motor, that wouldn't be as redundant, and that's not what we needed for our design. So we have to use 2 motors, which doesn't allow us to have a 2 motor launcher and a motor turret, or makes us either do an option or combination with servos. So that's quite a big con for us. It adds design restrictions on the rest of our robots. So I'll go into a bit of detail on this. So at the start of the season, we knew we wanted to sort, but we also knew we wanted a double intake. So because we wanted artifacts to come in from both sides, it would be very hard to do a Lindexer or even a Spindexer, because we would have needed to do a lot of software and mechanical, like a lot of rigorous testing. And with our short season, that wasn't really possible. So that's driven the idea of our sorting, because we've found that's actually one of the only ways we can do a double intake and still sort within the robot. And it takes up, yeah, so that's it. And then the final con is it takes up a bit of space. So that's it. Do any of the rest of my team anything else to add? No, we're all good. So yeah, that's it.
Okay, so if anyone has any questions about any of the presentations you've seen today. If not, I guess we can finish the conference. Thank you all for joining, and good luck this season. Bye.
Thank you.
Thank
Happy
you.
to
Thank you very much.
Thank you.